Kia ora everyone. I've been embarking on a journey, and that journey is learning programming. To me, programming is a powerful tool, and I've been learning programming through Python, which is an easy way to get into learning this very important skill. In this video, I want to go from 0 to 100 in Python. So let's not waste any time. Let's jump straight in. Straight in. And let's do some Python. So the first thing I'm going to do is I'm going to show you some dependencies. Okay, this is a bit advanced at the moment, but this is for anyone who wants to set it up. And you can see that pandas is installed on here. They'll make sense a bit later on. Okay, so let's open up IPython. Great, so IPython, or also known as interactive Python, is a way that allows me to type on Python code and also be interactive. Great. So the first thing we're going to do is the most notorious thing to do in learning a language, and that's printing hello world into the console. So to do that, we just do print hello world. And you can see that it prints hello world onto the console. The next thing is we're going to look at comments. So a comment is given by a hash, okay? So this is a comment. And comments are really important if you want to document your code. And this stuff is not actually ran. So Python doesn't run this. So you could write something that's completely wrong and it won't run it. It won't say there's an error. Okay, great. The next thing we'll do is variables. So num equals 10 and string equals this. Great. So a variable is a way to store data, and we can print this data off. So print num. That prints the number 10, print, and that prints the string. We can also print this in one line using if strings. The special thing about if strings is that anything inside curly brackets gets evaluated. So you can see here we have num, and it looks at the variable and prints off what's inside the variable. For example, num, and a string does the same thing. This is a string. Great. Now, with variables, variables have types. So for example, num is an integer and string is its namesake, a string. And I can show you that. Great, so you can see that num is a class, or it's a type integer, which is int, which is short for integer. And the string is a class str, which is short for string. Now you got those things wrapped underway. The next thing I'm going to do is focus on functions. So it's good practice not to repeat yourself. In a function, what we can do is we can define a block of code. We can call that function without having to write all this code again. So the function we're going to be looking at is the Fibonacci sequence. So what is the Fibonacci sequence? Let's jump straight into it. Great. So a Fibonacci sequence can be defined as these numbers. So we can see here that the previous two numbers are summed together to give the current number in the sequence. So for example, with 2, that's basically 1 plus 1. With 11, that's 5 plus 8. So the next number in the sequence should be 11 plus 8, which is 19. We can create a function for this. So to define a function, we use the def, and we're going to take some sort of input, which will be n. N will be the nth number of that sequence. We're going to use what's known as typing. So what the int means is that we want n to be an integer or a number, and the function is going to spit out another number or an integer, or that'll be the number in the Fibonacci sequence. What I've written here is a docstring. A docstring is a good way to describe how your code works or how a function works. Oh, on your bed. This is a great segue into what if statements are. So if this is evaluated true, then then the function will return 0. If it's not, then it'll go to the next statement, which is an else if statement, or ELIF. And it looks at if n is equal to 2 or 3, then you're going to get 1, which corresponds to the first one here, the second one there, and the third one there. And then if it's not 1, 2, or 3, it's going to actually do what we call a recursive function. So it's actually going to call the function itself for the previous number and the number before that. So if I do F9, then we'll get 21, which is not quite correct because I made a mistake here. That should be 13, and then 13 plus 8 equals 21, so I got that wrong. So you can see how humans can make mistakes. So the next thing we're going to look at, so we looked at integers and strings. there's another data structure called lists, or data type called lists. Let's have a look at that. So a range is basically a number that ranges from 0, not up to, but not including 10. And we turn this into what's known as a list. And there we go. All the numbers going from 0 all the way up to 10 in a list. And we can call numbers in that list, just like so. So 0 is actually the first number of that list. We can do what's known as a slice. As you can see here, we're going from the second, starting at 0, 0, 1, 2, which is the 2. And we're going to do 3, up to but not including 4. So that's why we get 2 and 3. This will give the last number on that list. We've used -1. And what we can do is we can reverse the order of that list using this magic sort of notation here. You can see instead of going from 0 to 9, it goes from 9 to 0. Now lists don't have to be limited to just integers or numbers. We can put functions in those lists. Let's have a look at that. Great, so you can see what I've done here. I have defined 3 functions, and we can put that into a list. And we can see here we've got our list of functions here. And we can actually evaluate each of those functions using what we call a for loop. And there we go. So we can see that it's printed off all those functions there. So we know that 2 plus 2, which was above here, 2 plus 2 equals 4. 2 to the power of 2 equals 4. And 1 over 2 equals 0.5. You can see the mistake I've made here is that we actually get a float. 0.5 is actually not an integer. It's actually what's known as a float. But there's no error thrown because Python doesn't actually look at the typing. It's actually used by something else. Great. So this is a good segue into for loops. For loops are a way of looking at each element inside an iterator. So for example, a list of numbers is iterable. And what a for loop does, it can look through each element of that list. So we can go back to our Fibonacci example for I in list. Oh, there's a bit of an error. And here we go. So we've got all our numbers printed out here in the Fibonacci sequence. Instead of doing that, we can put that into a list. So we create an empty list. And here we have a list of all our numbers here. Now, this would be a good time to introduce a list comprehension. So Python, this is very, very popular in Python. Python's very famous for this. List here, an empty list here, and having to write multiple lines of code. We can do this all in one line. Output 2. Output 2. And here we go, a list of numbers, all made in one line using a list comprehension. Great, so we covered a few things. Variables, how to print, lists, for loops, functions. Now let's have a look at importing libraries. Now, there are very, very smart people in the world. They've solved problems that I couldn't do in my entire lifetime, but they've offered their code up for free. So we're going to import their code to solve our problems that we need to do. Great, so remember talking about pandas initially? Now we're going to be using pandas. So import pandas as PD. So what we've done here is we've imported the pandas library and we're given the alias PD. So that saves us having to write pandas dot blah 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 all the time. We just write PD. With the recursive function, as that number grows, the complexity or the time required to complete that function is going to take longer and longer and longer. And we're just going to do a range of 30, we'll do maybe the first 32 numbers. Remember, range goes from, well, actually we'll start at 1. And it'll go up to the 32nd number, but not including that 33rd number. Okay, so t equals time it. So I'm actually going to use a special function called a magic function, which is exclusive to interactive Python. What time it does, it allows me to time how long it takes to run a particular piece of code. We're going to be using some special tags. So in1 just means that it's going to run that piece of code once, okay? And -o means we can store that value as a variable. You go fi, and you can see it's running all the loops and codes. You can see it's taking longer and longer and longer, and now it's done. And we should have all our numbers, or how long it took, stored in here. So you can see it's very quick to begin with, and you can see it starts slowing down. And Pandas is a very popular data analytics library. And what we can do is we can create a table that represents this data. So we create a data frame. And by importing the pandas function, we have access to what's known as data frame. And data frame allows us to build tables. Great, and we're going to use def head, so that prints the first 5 values on that table. And we can see that there. I've got def tail, and it's going to print off the last values. Now we're going to import another library called matplotlib, another popular data analytics library. This is going to allow us to create some graphs. Great, and I'm actually going to plot this, def plot. Great, so I should have that saved. And there it is right there. You can see the time created, 12:14. It's 12:14 right now. And let's have a look at it. Let me just blow that up. And we can see here, if I'm not in the way, I am in the way. So you can see that here, as the number of numbers in the sequence get called, the time it takes to perform that function increases almost exponentially. Now, coming back to our IPython, I've just had to rerun a few statements. But what we can do with data frames is that we can perform some functions on them. For example, we can sum all those times that we have. So here we are. All those times we have here, we can sum them together to work out what our total time was. So for example, it took 0.9 seconds to run all these functions here. Now I think it's a good idea to introduce ourselves to the concept of dictionaries. Dictionaries have what's known as a key and value pair. Let's have a look at them. So let's create a dictionary. And a way to refer dictionaries is that we would use this. So we would give the key, it'll give us the corresponding value. If we give something that's not a key, for example, so we go key 3, then it's going to spit out an error. So alternatively, what we can do is we can use the get method. So this will print off a value if it exists. If it doesn't, it's going to print off, it'll return none if it doesn't exist in there. And key 2 did exist actually. And in this case, this key does not exist in our dictionary, so we get none returned, and it's going to be true. It's going to value this to true. We can even perform for loops on our dictionaries. And there we go. So it's gone through an entire dictionary, printing off the key and printing off the corresponding value to that key. Great. So one example is we could incorporate our key into our Fibonacci function. We notice that with our Fibonacci function, as the numbers grow, it gets slower and slower. So what we can do is we can create a dictionary to turn it into something of a cache. So let's try it. We're going to create what's known as a cache outside the function, and we're going to create a new one. We'll call it fbeta. And once again, it's going to take an integer and repeat and spit out an integer. Great. So let's go through this function in greater detail. So once again, we've got our doc string. Now, initially, this first statement here, this all cache.get n-1 is basically checking that if this number exists, we get true. And we want to make sure that both the previous number and the number 4 exists. And what we'll do, it'll look into our cache and just return the sum of those two numbers, rather than calculating out everything again and again and again. And if it doesn't exist, then it will actually work it out, and it'll store it to the cache, so it can be referred to in the next cycle of recursion. So let's test our function to see how it works. You can see it ran a lot faster for the same number of values. And let's save that to our data frame. And see, we've got our data frame here. We have one column for our previous functions, and we have another column for our other ones. And we can compare near the very end how those times where f beta has stayed pretty small, and you can see f is starting to grow. And what we can do is we can plot that one. And we can see here, if we look at the graph here, we can see that the old function is growing, but then the new function that we created with caching strategy, the times stay pretty much the same. Great. And we can look at our cache, and we can see all the numbers that are being stored here. So I hope that's really cool. Now, thank you guys for watching this far into the video. I know it's not fun watching me type, but now you know the basics of Python, okay? So now go build something. Go be somebody. So whatever it is, big or small, just make it. Don't be afraid to make mistakes, but do ask for help when you need to. And now I want to say the key to learning the program is building a habit. Small improvements every single day. Rome wasn't built in a day, and neither will your programming skills, okay? So make some time in the day, maybe about an hour a day, just to learn programming, and then you'll be amazing in a year's time. Not me, but you will be amazing in a year's time. And remember, finally, if you have any feedback, suggestions, please comment below, okay? Always respect yourself, stay Pythonic, ka kite ano.